Hello and welcome to the video. In this video, we will discuss the properties of phenolic compounds. Properties mainly fall under two headings, namely physical properties and chemical properties. In chemical properties, we have already discussed the acidity of phenol and the effects of substituents on the acidity, and also we have done the comparison of acidity with alcohol in the previous videos. In this video, we will be particularly discussing the properties of phenols. First of all, we will see the physical properties. Phenols are either solids or liquids, but they will have a characteristic odor which is referred to as a carbolic odor or a carbolic smell. Generally, phenols are insoluble in water. However, lower phenols and polyhydric phenols, they are soluble in water due to extensive intermolecular hydrogen bonding. Also, phenols have much higher boiling point in comparison to the corresponding alcohols. These are the notable physical properties of phenols. So we have seen that phenols, they can form intermolecular hydrogen bonding. In the same fashion, they are also capable of forming intramolecular hydrogen bonding. That is, if certain groups like say nitro group or aldehydic group or carboxylic acid group, etc., if present in the ortho position to the phenolic OH, then they are capable of forming what are known as intramolecular hydrogen bonding. So the consequence of such intramolecular hydrogen bonding is that such isomers, they are more volatile and insoluble in water than the meta and para isomers. Now we will see the chemical properties of phenols. So chemically speaking, phenol molecule consists of two groups, namely the phenolic OH group and the aromatic nucleus, or the phenyl group or the aromatic nucleus. Thus we have two entities or two different functional groups in phenol. So phenols will be showing the chemical properties due to both these groups. First of all, we will discuss the reactions of phenol due to the phenolic OH group. Phenolic OH groups, they are actually the OH groups which are directly attached to the aromatic nucleus. On the other hand, if the OH group is attached to some alkyl groups, then it will be alcohol. So that is a chemical difference between phenol and alcohol. In the case of phenols, the OH group is directly attached to the benzene nucleus, while in the case of alcohols, the OH group may be attached to some alkyl groups, say like this example C2H5OH, means here the OH group is attached to the alkyl group, while in the case of phenols, the OH group is attached to the aryl groups. That is a fundamental difference between phenols and alcohols. Now we will discuss the reactions of phenolic OH groups. Due to the phenolic OH groups, phenols are acidic in nature. That we have already seen in the videos 1, 2 and 3. And you are directed to watch out all those videos 1, 2 and 3, and the link of those videos are given in the description box. Next reaction is with neutral ferric chloride. All phenols, they will give characteristic colors. For example, particularly if we take phenol, it gives a violet color. If we take 2-naphthol, then it will give a green color with neutral ferric chloride. If we go for hydroquinone, it gives a brown color. This coloration is actually due to the formation of a complex with the ferric ion. The reaction is shown here. Actually, this ARO group is something like ARO group, that is the aromatic O minus, that is phenate ion, phenate like ion, that is the ARO group. Next reaction is the zinc dust distillation. Phenols, when subjected to zinc dust distillation, what happens is that the zinc react with this oxygen, liberating zinc oxide, and we will be getting the corresponding aromatic hydrocarbon. Next reaction is distillation with PCl5. With PCl5, phenol gives the corresponding aryl halides. Particularly if we take phenol, then we will get chlorobenzene. We will see how this reaction occurs. PCl5 may be visualized as PCl3 attached to two chlorine atoms like this. And the reaction takes place in this manner. POCl3 will be liberated. HCl will also be liberated in this way. Therefore, liberation of HCl and liberation of PCl3 happens, and the remaining chlorine atom will be attached to the aromatic nucleus to get chlorobenzene. Next reaction is with ammonia in the presence of anhydrous zinc chloride. We know that anhydrous zinc chloride is a dehydrating agent. So with ammonia, the reaction takes place like this. Ammonia may be represented as HNH2, and therefore in the presence of dehydrating agent, water will be liberated in this way, and therefore the remaining NH2 part will be added to the aromatic nucleus to get aromatic primary amines. So if we take phenol, we will get aniline. Next reaction is with alkyl halides or with dialkyl sulfates. Again, in the presence of alkali, the phenol will be alkylated at the phenolic OH. This H will be alkylated. So in the alkaline medium, first of all, this H will be replaced by Na. And if you are taking alkyl halide, say methyl iodide, the reaction takes place in this way. Sodium and iodine will be liberated as sodium iodide, and the remaining CH3 will be attached to the oxygen atom to give the methyl phenyl ether or anisole. So from phenol, we get methyl phenyl ether or anisole. The same reaction may be carried out with the dialkyl sulfate. Instead of alkyl halide, we can also use dialkyl sulfates. The formula for dialkyl sulfate, say dimethyl sulfate, is like this. Next reaction is a reaction with acyl halides. Say, for example, if you are taking acetate chloride, the reaction takes place in alkaline medium. Phenol, when reacted with acetate chloride, this hydrogen and this Cl will be removed as HCl, which will be in turn neutralized by the NaOH of the medium, and we will be getting the acetate, phenyl acetate, that is this CH3CO group will be added to this oxygen to give the corresponding ester phenyl acetate. Instead of acetate chloride, if you are taking benzoyl chloride, say in the presence of benzoyl halides, and if we carry out the reaction in alkaline medium, then the reaction is termed as the Schotten-Baumann reaction. Here the reaction takes place in the same way as we have explained in the case of acetyl chloride. Here we are taking benzoyl chloride, and with benzoyl chloride in alkaline medium, the reaction takes place in this way with the liberation of HCl, and therefore we are getting an ester. that is phenyl benzoate. This reaction is a special reaction and it is named as Shorten-Bowman reaction. Now we will discuss the remaining chemical properties of phenols in the coming videos. So thank you.